Hi, and welcome to the Azure Sentinel Notebooks channel. My name is Jannie Li, and I am a software engineer on the Microsoft Threat Intelligence team. Today I'm going to be talking about the Guided Hunting Base64-Encoded Linux Commands Notebook. This notebook is a collection of tools for detecting malicious behavior on Linux machines when commands are Base64 encoded. This behavior is commonly seen in crypto mining attacks. The notebook allows you to specify a workspace and highlights as well as categorizes potential malicious behavior within that workspace, allowing you to hunt and pivot on key entities. The notebook primarily utilizes Azure Sentinel syslog data and telemetry from the MSTIC research branch of the AU-OMS tool. Details on how to set those up, as well as an in-depth written guide on the notebook, are available in the description below, as well as on the Microsoft Tech Community blog. To launch the notebook, simply find it in the Notebooks tab of Azure Sentinel, save it, and click Launch Notebook. Once you've opened the notebook, you will see a detailed description of all the data sources and Python libraries used within the code and links to more information on each. To set up the notebook, simply run the first code cell. This cell will confirm that MSTIC and Python are properly configured. In this case, we have pre-run all of the cells in the notebook, but in your case, you will simply need to press the Run button. You can then use the following cells to log into the workspace. Your workspace and tenant IDs should be set up in the MSTIC config YAML file. There are more details on how to do this in the blog, and you can also use the links in the notebook to get more information. Now that your data is connected to your notebook, you can pick a time frame of interest. The following cell will then extract all Base64 commands from within that time frame. You can browse commands in the data frame that results. To make it easier to browse those commands, the next cell will categorize each decoded command in categories, specifying what each does. You can also add your own categories if you are looking for a specific behavior. Next, the notebook uses GTFO bins for a more open source classification of bash commands, frequently exploited by attackers. Running the first cell will give you some reference text that you can read for more context. Links to the website are also available for more details on the classification. In the final data frame, you will also see links to each GTFO bin. Clicking on the bin will send you to the website for more in-depth information. The notebook then runs a series of analyses to generate a ranking of commands most likely to be malicious, with the most potentially malicious commands listed at the top of the data frame. It begins with a frequency analysis, as commands run repeatedly can be a sign of malicious intent. The total score is updated with each analysis run. In this case, it only contains the frequency score. The notebook then extracts indicators of compromise within the decoded commands using TI sources to research whether they are connected to potential malicious behavior. You can set this up in MSTIC. The notebook provides links for more information on how to do this. You can also look up specific indicators of interest by selecting them and using the selectors. This data frame shows all of the extracted IOCs. You can confirm which TI resources you would like to use. In this case, we use VirusTotal. We've chosen all of the IOCs to look up in this situation, and you will get a data frame of all of the results. TI scores are calculated based on those severity results. The final scoring category is based on related alerts. You can set a new time frame for when to query for alerts occurring on machines where Base64 commands were found. Running the code cell will provide a summary of alert types, as well as how they are related, and a more detailed data frame. Any scores generated here will be added to a total score for the final score. You can view the final rankings by choosing which columns you're interested in seeing and running these next cells. Cells highlighted in red have relatively high scores for their category. You can also filter based on a scoring column with a cutoff slider. This next bar chart below breaks down scores by which particular score contributed most to the total score, providing insights on which score points most toward a malicious attack. Finally, we provide a behavior timeline allowing you to adjust your time frame if you should notice anomalous behavior, as well as place all queries into context. We hope you found this video helpful, and thanks for watching.